What happens to your brain on sugar? It's in your breakfast, your coffee, your healthy snack, and your midnight craving. It's the most consumed psychoactive substance on the planet, and most people have no idea it's doing to their brain exactly what they'd never accept from anything else. This is what actually happens. Step by step. The second sugar hits your tongue, your brain reacts before it even reaches your stomach. Taste receptors signal your brain instantly. Dopamine releases. A small hit, just enough to say, more of this. That's not enjoyment, that's a trigger. Your pancreas gets the signal and releases insulin to manage what's coming. Your gut sends confirmation up through the vagus nerve. Your brain is already building a map. Sugar equals reward. This happens in seconds before you finish the bite. The onset sugar enters the bloodstream as glucose. Your cells absorb it. Your brain, which runs almost entirely on glucose, gets a fresh fuel supply. For a moment, everything sharpens. Focus improves. Energy lifts. Mood rises slightly. You feel more capable, more awake, more present. This is real. Brain is genuinely running better on fresh fuel, but here's what most people miss. That feeling isn't sugar working. That's your brain returning to baseline after being slightly depleted. You weren't being enhanced. You were being refueled. The difference matters more than most people realize. The peak dopamine is now fully engaged. Your brain's reward circuitry lights up in patterns that researchers have compared directly to addictive drugs. Not identical, but structurally similar enough that the comparison keeps appearing in neuroscience literature. Your nucleus accumbens, the brain's reward center, is firing. Opioid receptors activate. Brain doesn't just want more sugar. It starts building a case for why it needs it. Feel good, comfortable, satisfied. And your brain is quietly filing this moment under. Do this again. This is where the trap is set, not in the crash, in the peak. Because the peak feels completely normal. It doesn't feel like a chemical reaction, it feels like happiness. Crash insulin has done its job too well. Blood glucose drops sharply, sometimes below where it started. Your brain, which just had plenty of fuel, is now running low again, faster than before. Fatigue sets in. Focus breaks apart, irritability rises, concentration slips. You might feel a low hum of anxiety or a heaviness that's hard to name. And then the thought arrives, something sweet would fix this. That thought isn't random, it's your brain pattern matching. It remembers exactly what made it feel better 45 minutes ago, and it's asking for it again. This is the cycle. Not a metaphor, a literal neurological loop that repeats every time you feed it. What happens over time? One crash is nothing. The brain is resilient, but repeat this cycle daily, which most people do 3 to 5 times before noon, and the brain starts to change. Dopamine receptors downregulate. This means the same amount of sugar produces less reward, so you need more to feel the same. It's tolerance, the same mechanism that builds in every addictive substance, just slower. Insulin sensitivity drops, cells stop responding as efficiently, pancreas works harder, blood sugar becomes harder to regulate, the brain itself shows structural changes with chronic high sugar intake. Inflammation increases. The hippocampus, your memory center, shrinks under chronic inflammation. Learning becomes harder. Memory becomes less reliable. This isn't about diabetes. This is about cognitive function, about who you are when you think. Addiction question. Sugar actually addictive? The research is contested. Officially, sugar use disorder isn't a diagnosis, but the behavioral and neurological patterns match addiction criteria closely enough that the question doesn't go away. Animal studies show binging, withdrawal, craving, and relapse patterns with sugar. Human studies show activation of the same reward pathways triggered by cocaine and alcohol. The debate is about degree, not mechanism. Here's the practical answer. If you've ever tried to cut sugar completely and felt irritable, foggy, and inexplicably miserable for 3 to 5 days, that was withdrawal. Your brain had adjusted to a chemical baseline that included sugar. Removing it cost something. That's not a character flaw. That's neuroscience. The hidden layer. Sugar doesn't just affect your brain through dopamine. It affects cortisol. High sugar intake disrupts your stress hormone regulation, making you more reactive, more anxious, less emotionally stable over time. It affects sleep. Blood sugar swings at night fragment your sleep architecture. You might stay unconscious for 8 hours and wake up exhausted. The brain never fully consolidated, never fully repaired. It affects serotonin indirectly. Your gut produces most of your serotonin. Chronic high sugar damages gut microbiome diversity. Less diversity, less serotonin precursor production. Less serotonin, lower baseline mood. More vulnerability to depression. Sugar isn't just an energy source. It's a variable inside nearly every system that determines how you feel, think, and function. The closing truth. You were told sugar was a treat, a reward, something you earn, something celebratory, something harmless unless taken to obvious excess, but your brain doesn't experience it as a treat, experiences it as a signal, chemical instruction, a loop trigger. The industry that profits from sugar spent decades funding research that pointed at fat, at salt, at anything else. The same playbook used by tobacco, the same delay of the same truth. Sugar doesn't make you happy, it makes you familiar with a feeling that requires more sugar to maintain. The brain you're running on right now has been quietly shaped by every cycle you fed it. That's not a reason for guilt. It's a reason to understand what's actually happening, because you can't change a system you don't understand.